Hi, my name is Abel, and I'm so excited to be here today to talk about Microsoft's DevOps transformation. But before we begin, let's do a quick introduction. So again, my name is Abel, and I'm a principal cloud advocate and the DevOps lead here at Microsoft. I've been writing code now for over 20 years. It's what I love. I eat, drink, and live writing code, right? It just makes me happy. And I've been doing DevOps for quite some time too. And right now, I'm super lucky because I lead a team of 5 DevOps practitioners, where our sole charter is to help everybody get into Azure using DevOps best practices. Now notice, I didn't say you had to use Microsoft tooling, right? I didn't say you had to use Azure DevOps Services or GitHub Actions, because Azure literally doesn't care. Azure is an open system, an open platform, so you can use whatever tooling you want to get into Azure. So what that means is, guess what? You can use whatever you want, and we as a team, we just want you to help get into Azure using DevOps best practices. So we are a resource. Please do use us. So how do we get a hold of us, right? How do you get a hold of us? Well, don't email, because I really hate email and I don't read it very often, so I'm about 2 weeks behind. But I'm on Twitter all the time. So if you tweet at me, and especially if you hashtag it LOECDA, that's like our bat signal. Me and my team, we will see that and we will answer your questions. And if we can't answer your questions, we will find the people at Microsoft that can. So again, we are a resource. Please do use us. All right, so before we talk about Microsoft's DevOps transformation, we should probably level set on what DevOps is, because if you ask 10 different people what DevOps is, you're probably going to get 20 different answers. So at Microsoft, DevOps means something very specific to us. DevOps is the union of people, process, and products to enable the continuous delivery of value to our end users. So I said this really carefully because every word has meaning, right? Notice I didn't say continuously deliver code, because what will that give us? Piles and piles of code sitting on a source control server somewhere. That doesn't do anybody any good, so who cares, right? And notice I didn't even say continuously deliver features, because we could be delivering feature after feature, sprint after sprint. But again, if this is not what our end users need or want, why are we wasting time, right? It's about continuously delivering value. So why is this so important? Well, the bottom line is the speed of business is so crazy fast today that the only way dev teams can keep up is if they adopt DevOps best practices. And if they don't, they won't be able to keep up. So here's the sad truth. If you don't adopt DevOps best practices, your competitors, they either have or they will. And once they do, they will out-innovate you. And when that happens, you become obsolete. And none of us wants to be obsolete. So this right here is the exact position Microsoft found themselves in around the 2010 timeframe, right? Back then, we were still delivering code once every 3 to 4 years, but our competitors were innovating faster and we were losing customers. And this was a very scary place for us to be, and we knew we had to change. We knew we had to adapt, shift, and adopt the DevOps best practices. However, this was very difficult to do, and one of the things that we had to learn is this. If it hurts, you need to do it more often. So when things hurt, we usually tend to avoid them, right? And what really hurt for us was pressing that deploy button. Because every time we press that deploy button, guess what? Things would break. So what did we do? It hurt, we tended to avoid it. So if I had some changes to check in, maybe I had like 20, 50 lines of code to check in, I would avoid deploying. I'd say things like, well, why don't we wait until the end of the sprint? Because I knew if I pressed deploy, things would break, and then it would be a big headache, right? Eventually it got pushed out even from the end of the sprint, and we'd be like, well, why don't we deploy at the end of the month, or maybe at the end of 6 months? I might even get pushed out all the way to the end of the year even. And now what was just 50 lines of code, now it's become thousands of lines of code that changes. So of course, if we try to push into production, that just makes everything so much worse. So of course things would break. So this was a very important lesson to learn, which is if it hurts, don't avoid it, do it more until you get better at it. So that's what we did, right? We built out these DevOps pipelines, we pressed deploy, and guess what? Everything broke. But that's okay. We fixed it and tried it again, and still everything would break. But slowly, over time, iteration after iteration, we slowly got better until eventually today we can press that button and we know our deployments work because it just works every single time, like clockwork. So how cool is this? Remember, there's that saying in our industry where they say don't deploy on Fridays, because if you deploy on Fridays, then you're going to have to work all weekend to get everything working. We don't worry about that anymore because we know our pipelines work. I can press that button on Friday, we can deploy, and everything just magically works. Why? We know it because we do it over and over again. We found what hurts the most, which was our pipelines, and we slowly improved upon it until today, they just work. All right. So our DevOps story begins when we first started, right? Microsoft came into being around the 80s, 90s, and the early 2000s. We dominated, right? But the way we did things was interesting. We would deploy new code where we put out a new product every 3 to 4 years. So every 3 to 4 years, it'd be a new version of Windows or a new version of Office or SharePoint, or for my team, a new version of TFS. And that worked great for us back then. We were very waterfall-like. But again, the world started moving much quicker, especially right around the 2010 timeframe. And we knew we had to make changes. And one of the places we had to make changes is our organizational chart. So this picture here, I love it. I think it's hilarious. The first time I saw this, Scott Hanselman showed it to me. And yes, it is a joke. But like all jokes, there's some grain of truth to it. So if you look at how Microsoft is organized in this cartoon, it has all these little islands, right? Or all these big islands. And each island had deep hierarchies within it. And each island for us would represent a product group. So one of these islands would be the Windows team. One of these islands would be the SharePoint team. One of these islands is the Office team. And one of these islands would be the Azure DevOps Services team or the TFS team. And that would be my team, right? So that was great. We had all these separate teams, but they were all islands into themselves because we got to decide exactly how our team wanted to be structured. We got to decide how our team functioned and all of that. But the best part is each one of these teams had guns pointed at each other, right? And we really were like that, where we were hyper competitive against each other. So back when we first came about, we created this culture because we thought that if we fought each other tooth and nail and competed against each other, by the time the product would go into production and go out to the public, the product was forged in fire, which would make it better than ever before, right? So that was our thought process. And back when we were deploying code every 3 to 4 years, that worked out pretty good for us. However, if you're trying to move quickly, and you have all these guns pointed at each other and you're fighting each other constantly, you are not going to be able to move quickly because you're constantly fighting. And that's exactly what we found. We created this very toxic environment where everybody fought with everybody else. And to really be successful at DevOps, you need to be collaborating and working across teams constantly. So this was a huge blocker for us. Luckily, around the same time frame, we got a brand new CEO by the name of Satya Nadella. And he said, you know what, this worked great for us before, but if we continue down this path, we're going to become obsolete eventually. So what we want to do is create something called the One Microsoft Initiative, where we are one company and we're all working together to be successful no matter what it takes. Put your guns away and everyone needs to work together. He also had the idea that we should have one engineering system. So by that, I mean our build systems, our release systems, our source control systems, our tools, so on and so forth. And back in the day, we as a group, as each individual product groups, we could pick and choose exactly what type of tools we want, which meant we all used different tooling. And that meant it was extremely difficult to collaborate with people that were not in your team because they would have a complete different source control system, a complete different build system. You didn't even speak the same language when you worked across teams. It became crazy difficult. So Satya said, one of these things we have to do is create one engineering system. So then he asked an interesting question, which is, which system should we use? And then he came up with the idea of, don't we have a DevOps system in-house? And that made me super happy because I was like, yes, that's Azure DevOps Services, or back then it was called TFS, because that was my team. But then Satya asked a very embarrassing question, which is, who at Microsoft is now using TFS? And the answer was no one, not even the TFS team. because we use other systems. And Satya said, this is ridiculous. The only way for us to build a world-class DevOps system is if we use it ourselves, because then we'll know what works, what doesn't work, and we can go in and fix what doesn't work. So that's what he mandated. Across our entire Microsoft, we're going to use one engineering system, and it's going to be Azure DevOps Services. Now, for those that don't know, Azure DevOps Services is everything you need to build your software, for your software project. So you have ways to track your projects. You have a CI/CD system. You have your source code repository system. You even have things like a manual test case system and also an artifact repository. So again, everything you need to run your software. And we know this works because I love this slide because it shows the numbers that we use. And this is from 2 years ago. So the numbers today, they're even bigger, right? But how many engineers use Azure DevOps Services? 96,000 engineers every single month, every single day. How many builds happen per month? 6.3 million builds happen. How many work items are viewed every day? 5 million work items. How many deployments happen every day? Over 163,000, right? So we know Azure DevOps Services scale because we use it internally. And these are just our numbers. It's not adding our customers' numbers who use Azure DevOps Services as well, right? And our numbers, our version of Azure DevOps Services is exactly the same as everyone else's. It's not a special version. So yes, we know it works because we use it internally. All right, back to the story. Our journey, like I said, we used to deliver new software every 3 to 4 years, right? Around the 2010 timeframe, we started realizing we were being out-innovated, and it was really bad, right? So let me give you an example. Around the 2008 timeframe, we came up with a new thing for work item tracking. That was the team that I was working on then. And I was very happy. I told my friend, he tried it out, and then he called me on the phone and said, hey, that's a neat feature you wrote, but there's a bug. Bug? I don't write bugs, right? But I jumped in there, checked it, turned out there was a bug. So I fixed it, checked it in, called up my friend and said, hey, I fixed the bug. And now you can see the fix in 3 years. Right? That's crazy. However, that was the speed we're working at. So we knew we had to increase our speed. So around the 2013 timeframe, we increased our cadence. So what we did was every 3 to 4 months, we would send out a service pack to our end users and said, install this. But this put us in a very weird spot because it made us both move too quickly and also too slowly, both at the same time. And let me explain what I mean. We were moving too quickly because every 3 to 4 months, we expected our customers to take this, install it. But to install it, they would have to bring TFS down, install it, bring TFS back up, and usually TFS probably wouldn't work. So then they'd have to tweak it to get it working. So all told, TFS would be down 1 to 2 days. And they were like, wait, you want us to bring our engineering system down every 3 to 4 months for 1 to 2 days? Are you crazy? We can't do that. So then they would stop installing these service packs and they would fall further and further behind. But the sad truth is, even if they installed these service packs every 3 to 4 months, our competitors were still moving quicker than us. So we knew we had to move even faster. And to do that, we had to go into the cloud. Because by going into the cloud, that now lets us move at cloud speed. And what do I mean about cloud speed? Every 3 weeks, like clockwork, new features just magically light up in Azure DevOps Services, like clockwork. And what we don't tell people, but I'll tell you guys because I think it's super cool, every day, multiple times a day, we are pushing into production, we're pushing bug fixes. So every day we're pushing into production. Why? Because we can, because we know we can move at that velocity. So we are so advanced DevOps-wise. I love showing this. This is our definition of done, and it's a very mature definition of done. So not only does a user story have to be code complete, and not only do we have to have a unit test that tests this particular user story, we're not considered done until it's pushed all the way into production. And it's still not considered done until it's gathering telemetry and sending that telemetry back to us, right? That's how important telemetry is. Now, this is a very advanced definition of done, and people always ask me, hey, should that be our definition of done? And I'm like, no way should it be, right? You never start out with something crazy. Because remember, DevOps is a continuous journey of improvements from one iteration to the next iteration. So that's what it's about. After your iteration, you need to figure out, hey, what hurts the most, and just fix that. And slowly over time, your definition of done will evolve until it becomes more mature. So don't try to bite off too much at once. All right, something else that we had to change is our team structure. So our team used to be structured like this. We'd have program managers, devs, and our testers. But we had a very toxic relationship between our devs and our testers. In fact, they were fighting each other all the time. Now, as a dev, I actually viewed my QA team as my enemy. I was fighting with them all the time. And let me give you an example. At the beginning of the day, I would go into work and QA would give me a bug report, right? All the bugs they found from my code. And I would immediately get really mad. And then I'd start working through each bug one by one, trying to prove that I wrote my code correctly, and it's because they tested it wrong, which is ludicrous. Why did I view my QA team as my enemy? My QA team, they're my first line of defense and my best line of defense. But we had this toxic relationship that just existed at Microsoft. So part of that toxic relationship was caused by us as well. And I was part of this, and we didn't mean to. But oftentimes I would interview somebody for a position, and I'm a dev lead. So I would say things like, well, this person was great. I liked them, but I don't think they were technically quite strong enough. But they'd be great on that QA team. So we created this second-class citizenship with our QA teams. And again, that helped with this really toxic relationship we had. So what we needed to do, what we ended up doing, is we collapsed both teams and said, you know what? There's no longer devs. There are no longer testers. You are just engineers. And now quality is everyone's responsibility. Quality is every engineer's responsibility. So that meant as a developer, I had to upskill. In fact, everybody had to upskill, get cross-trained and get upskilled. Where as a dev, I had to learn how to build quality into my app as I was writing it versus just writing my code, throwing it over the fence, have QA find my bugs, and then try to tack quality on at the end, right? So I had to learn things like how to write good unit tests. I had to learn how to write code in a testable manner. I had to learn things like how to write automated UI tests and things like that. And on our the QA side, they had to learn how to write code as well. Because ultimately before they were just pure functional testers that clicked on buttons. So they had to learn coding. Now, not everyone could make this change. So we suffered attrition. It was pretty rough to make this change. And my attitude was terrible about this as well. When we first started getting trained for this, I pushed back really hard because I thought this was crazy. I'm a developer. I write code. I am not good at testing. My brain is not wired for testing. It's not in my DNA. I came up with all kinds of excuses until finally leadership came up to me and said, you have to change your attitude. And if you don't change your attitude, you're going to have to find a new job. I got really angry. I got very huffy. And for a while there, I thought maybe I should find a new role. I can easily find a new role. But then I looked at how much stock I had and I went, maybe I should change my attitude. And when I did, that's when everything changed, right? I literally had to learn how to write code again. I had to learn how to write code in a testable manner. And I had to learn about quality. And this changed everything. But again, not everyone can make this change, and we suffered attrition. Leadership didn't know how much we would lose, like how many people we would lose, but they knew we were going to lose a lot. And we ended up losing 20%, which is a crazy amount, right? Nobody wants to lose good engineers. And we lost a lot of very good, very senior engineers who could not make this change, both on the dev side and the QA side. But leadership also knew that this was a price they were willing to pay, because now they could replace these people with other engineers that bought into this mindset. And now we could move faster than ever before. Not just a little bit, but way faster. So this was a heavy price, but this was a price leadership was willing to pay. The other thing we did is we restructured our org chart and flattened everything out. Remember, we had this deep hierarchy? Well, that made it extremely difficult to make changes because in one particular feature, if you wanted to change that feature, it would span multiple teams, right? So to coordinate between them all, that became difficult. So we created what is called feature teams, where one feature team would own one feature all up. So they would own everything about it, right? The other thing is that this allowed them to be so much closer to our customers. Whereas before, if our customers wanted to give feedback about a feature, who would they go to? Because again, this feature spanned multiple teams to implement. But now there's a program manager that you can just reach out and talk to about your specific feature. It was so much easier for our customers to talk to us. In fact, now they can talk to us in so many different ways. They can talk to us through Reddit. They can talk to us through user voice. They can talk to us through Stack Overflow. They can even just use Twitter. Our program managers, that's all public knowledge. You can just tweet directly to one and say, hey, I love this feature, or this feature sucks, or can you fix this, blah, blah, blah. And by being this close to our customers, we can gather that feedback, and that helps us know, are we delivering value? And we can start delivering value faster than ever before. So this was super cool. But of course, by structuring our teams this way, right, by having these feature teams, that forced us to re-architect our application in a different way as well. So before, we architected our app in layers, right? You have the UI layer, the API layer, a data layer, and our teams were structured that way as well. We had teams that were UI teams, teams that were API teams, teams that were data teams. And again, there were so many teams. For one particular feature, it would cross through lots of different teams. Difficult to get work done. A lot of coordination was involved. So now we created these feature teams. And so now, instead of designing everything in layers, we have to design things in slices. So now one team would own everything all up, the UI layer, the API layer, the data layer. They would own, gathering the requirements to figure out, are we building the right things? They would own quality for this particular feature. They would own even the CI/CD pipeline. So they would own everything about this one feature. And again, because of that, we were so much closer to our customers, and now we were so much more agile. We can make changes within a feature. We didn't have to coordinate between all these other teams. It was so much faster and better for us. Now, each feature teams, to give you kind of an idea, we have about 800 engineers. We have about 60 some of these teams. Each team has about 10 to 12 people in them. And each team is self-managing, so they get to decide what they want to do. And we have teams on the East Coast of the United States, West Coast of the United States, out in India, all over the world, right? So this is very, very global. Now, before COVID, we required you to be with your team, right? So you could join whatever team you want, but you had to be co-located with your team. And the reason why we did this is because what we found out, we tried it differently. We tried it so you can just join whatever team because we have remote capabilities, but it became too difficult to schedule and coordinate between people from way, different time zones. It became very, very difficult. So we said you can join any team, but you have to be co-located. In this way, you can just have all of your meetings, you can coordinate. It's much easier to do it. In the COVID world, we are 100% remote. You can still pick whatever team you want to be on, but you have to be in a time zone close enough where you don't have these hurdles of coordinating, right? So that's still important to us. But it's kind of neat. Each one of our feature teams, they are independent from each other. So they're self-managing. So they're autonomous. But they're not 100% autonomous. Otherwise, it would be complete anarchy, right? It is controlled. So we have what we call aligned autonomy. Right? So there are certain things we align on, like the type of sprints that we do. You can choose what version of Agile. One team can be Scrum, one team can be Kanban, so on and so forth. I like Scrum. I'm a Scrum purist. But those things you can choose, but then there are certain things that we have to align on. Now, once a year, we have what we call the Great Sticky Yellow Note exercise, and this has been an amazing, successful experiment that we ran, which is every year, team members are allowed to pick which team they want to be on. So once a year, we have this exercise where the program managers, they say, join my team. My team's the best. We're using the latest JavaScript framework of the moment. Look how many customers we have. Look at all the cool technology we have. Join my team. And as engineers, we say, this is my first choice. This is my second choice. This is my third choice. And then based on availability, we get to pick which team we want to be on. Now, the interesting thing is most engineers don't want to change teams. They don't like change. They love the team they're with. They love the culture that is built. They love the people, right? You build friendships. But 20% of the engineers do want to change. And just by giving engineers the choice, this makes them so much happier. So again, this is one of those experiments that we ran that became incredibly successful, and we still do this today. All right, so other things that we align on is our sprints. Our sprints are 3 weeks long. We used to have every team can pick their sprint cadence. That turned into chaos trying to coordinate between all 60-some teams. Too hard. So now we say we start at the same time, we end at the same time. Our sprint length is 3 weeks. Why 3 weeks? We tried 2, and trying to coordinate through all 60 teams, there just wasn't enough time, it felt like. We tried 4, that just wasn't agile enough. It just felt like the sprints just lasted forever. We tried 3 weeks and we said, hey, that felt pretty good. So that's where we are, right? We're actually trying to implement 2-week sprints now, but that's a work in progress, and I'll talk about that more later. So how do we coordinate? At the beginning of the sprint, we have a sprint planning meeting. At the end of the sprint, we're done. When we are done, we press the deploy button and we deploy at the end of every sprint. If you don't deploy, what we found out is things just don't get done. And not because developers are lazy or engineers are bad, but by not deploying, certain things just don't happen. So we have a rule at the end of the sprint, always deploy. Now, our deployments take a long time because we try to deploy very carefully throughout the entire world. So we do something called safe deployment, where we first deploy to a small segment of the population, then a little bit more, then a little bit more, then a little bit more. So because of that, our deployments take up to a week long, right, from pressing that button. So at the end of the sprint, we press that button. The deployment can take up to a week, so sometimes it bleeds into another sprint. But we've worked through that, and that works as well. So this works pretty well for us. Trying to coordinate all of our teams is difficult as well, because you can't all sit in the same meeting, especially with all the different time zones and stuff. But at the beginning of the sprint, we create a sprint plan that says what we're going to do, and we email that to everyone. And at the end of the sprint, we say this is what we've accomplished, including a video of what we've done. So this has been an extremely good way for us to communicate what's happening across all 60 of our teams. So this is what it looks like, right? At the beginning of the sprint, we say this is our sprint plan. We use Azure DevOps services to track our work, which means this email just pretty much gets generated automatically. And at the end, we say this is what we accomplished, and we create a video. The only rule for this video is it cannot be produced, right? No smoke and mirrors. It needs to be the real thing. So that's pretty cool. And again, this has been a great way for us to communicate what we're doing, each team. And it's been a great way for leadership to see everything that's happening across all the teams. Before, we used to send this email out at the user story level, but what we found out is at the user story level, there was way too much detail. Most people didn't have the context to understand it at that level, so we moved it to the epic level, and now it's so much better. There's a lot less chatter. It just works out nice and clean. Now, across our teams, the way we do planning, first we have sprints, which is every 3 weeks. We have a quarter, which is every 4 sprints. We've got a semester, which is 6 months, and then, of course, we have our yearly plan as well. Now, I'm interested in sprints and quarters, right? Because a sprint, that's, as a team lead, that's what I'm worried about. Each sprint is 3 weeks long. I worry about my product backlog, how to prioritize that, and all that stuff. And every 4 sprints, I meet up with my sister teams, and we have meetings as well to help shake things out, right? Because these are sister teams, so these are teams where we share code or we're very closely related. We talk about things like what we've worked on, what we're going to be doing, and then a lot of information starts to shake out, right? So for instance, things like, oh, we're going to be changing this API, you use this API as well, how do we coordinate, things like that, or even things like, oh, my sister team, they need a widget for their UI. Turns out I've already built it in my last couple of sprints, why don't you just use it instead, right? So a lot of useful information comes out of this, out of these quarterly meetings. Leadership should worry about the semester and the strategy, because at every semester they have a giant meeting and they reprioritize our yearly plan as well. So every 6 months that gets updated. We even have rules in place where our leadership are no longer allowed to look at our sprint backlogs. Why? Because before, every time they looked at our sprint backlog, they would want to micromanage. They just couldn't help themselves. And the problem with that is that leadership did not have enough context to micromanage effectively. So because of that, we would waste a lot of time explaining to them why we couldn't do things the way they wanted us to, give them enough context, and we wasted so much time. So eventually we just finally said, you know what, leadership, you're not allowed in our backlogs because we don't need you to tell us how to manage our little section here. We need you to guide us. We need you to give us strategy, long-term strategy. That's what we need you for. So this was difficult for leadership to give up this control, but they realized the truth in this, and they realized that they were really slowing down progress, so they agreed to it, and now this has worked out really well. The other thing we had to fix is how we did quality. So before, we would write code until you finally got done with your code complete, pizza party time, right? But you weren't really done, because this is when QA would start testing your code, and that's when they would start finding the bugs. And now the dotted line, that's your bug count or your debt count. And because of that, it would build up and they would find a mountain of bugs, and then you would burn down your mountain of bugs, right? So this chart here is best case scenario, because most of the time there are so many bugs you can't burn them down fast enough or even get all the way done. Hopefully you just get quality good enough. And then the next iteration, you do the same thing, and this bug count just gets higher and higher. So we've all been in this position where an application is so fragile, every time you try to make a change, other things break, or you fix a bug and then 5 more things break. And we've even been in that situation where our application is so fragile, we can't add any new features because constantly we're just stitching things together and just making it work, right? So that's technical debt out of control. So that cripples innovation. So we needed to make sure that did not happen. So what we did is we came up with a rule that said at the end of every sprint, you must burn down all of your bugs. You cannot carry bugs from one sprint to the next. And we're so serious about this, we created something that we call the bug bar or a bug cap, which is every engineer on your team, they could only carry 4 bugs from one sprint to the next sprint. Why 4? Because in theory, we, or at least our engineers, can burn down 4 bugs within one sprint time frame. So the idea is we can spend one sprint and our product would have 0 bugs, right? And we are so serious about this, we have this bug bar. We actually have a report that shows what the bug bar is for each team. And if a team is over the bug bar, they're not punished, but they're not allowed to take on any new features. For the next sprint, they just have to burn down their bugs. And this isn't a punishment, right? This is just a way to make sure that we do not carry debt from one sprint to the next. And because of that, our quality is so much better than ever before. The other thing that we had to learn is what you measure really matters, right? So you have to measure very, very carefully, because if you measure things that don't matter, that drives behavior. So we have a mantra at Microsoft, which is measure the outcome that you want to happen. Don't measure the output, because if you measure output, your engineers are going to game the system and those numbers don't mean anything anyway. So to give you an example, things like code per coverage, right? Percentage of code coverage, that's actually an important number. But if my bonus was based on code coverage, do you know that will be 100% every single time? But that doesn't necessarily mean my unit tests are doing anything, right? Super easy for me to write a test that just touches every line of code, but doesn't test anything. That's the type of nonsense developers end up doing. So don't measure the output, measure the outcome that you want. So what's important? Things like mean time or cycle time. How long does it take to start work and then the work shows up all the way in production? Or how long does it take to have an idea and have that idea cycle through everything all the way out to production? How quickly do you find live site incidences in production? How quickly, once you found it, before you get the fix out into production, right? Things like that become really, really important. So we still do gather performance numbers about our individual engineers, but the important thing is we don't use these numbers to reward or to punish our engineers, right? I use these numbers to try to help my engineers, because again, if I try to use these numbers to punish them or to reward them, our engineers will just start gaming that system. Why? Again, it's just the way engineers are wired. It's that mathy brain we have, and there's nothing we can do about it. So I try to use these numbers to help. Right? So for instance, if I notice productivity has dropped for one of my engineers on my team, I will go up to them and I'll talk to them and I'll say, look, your productivity has dropped. I know this, but why? Is it because we're using a new JavaScript framework? We seem to trade those out every couple of days, right? Do you need more training? Because if you need more training, I can get you more training. Or is it just because you needed time to get used to it? So next sprint, you're going to be fine. If that's the case, carry on, right? Or are you suffering like problems at home? Is bad things happening at home? Do you need time off? Like I can do that as well. Or do you need resources to help? We can have resources at Microsoft that really help. So again, I don't use these numbers to punish. I use these numbers to help my engineers. Now, of course, this leads people to always ask me, how do you make your engineers do the right thing, right? Well, guess what? Our engineers end up doing the right thing because we make them feel the pain of their bad code. So what do I mean about that? I'm that guy that writes code at a crazy fast speed at Microsoft. I'm really, really fast. In fact, I'm so fast, I usually never even feel the pain of my code. because I write the code really quickly, throw it over the fence, QA finds my bugs, but I'm off doing something else. And by the time QA comes back with my bug list, some poor junior dev has to fix my bugs for me, to the point where I don't even see my bugs, right? I think I'm God's gift to programming. And I'm not, right? I'm a human just like everyone else. But I never felt the pain of my bad code. And now we do. We have another mantra at Microsoft, which is if you write it, you need to run it, right? So what this means is, what's the worst thing that could happen to us? If we get a live site incident, it's really bad, because Azure DevOps Services, the team that I'm associated with, our application runs, other companies use it, and if we go down, they can't do their business, right? They can't do their builds. They can't do their builds and releases. They can't plan, things like that. So we can't go down. So if something bad happens, Scott Guthrie gets called, which is our EVP. He's Satya Nadella's right-hand man. And he gets on the phone and starts calling all of the management chain all the way down until it reaches the program manager who is in charge of the feature that's causing this live site incident. And then this program manager is going to call the 2 people on his team that are on call. And there are 2 of them, and it rotates every single sprint because it's so horrible to be in this role. You get on call, you get this call that there's a live site incident, and it happens at 2 in the morning because it seems like it doesn't matter what time zone you're in, it always happens at 2 in the morning. So you get this call, you join this call bridge, your entire management chain is on it, and you get Scott Guthrie asking you every 2 minutes, did you fix it? Did you find out what's wrong? It is so stressful and horrible. And you are not allowed off this call until you've slapped a Band-Aid on the problem and you made the problem at least temporarily go away. But you're still not allowed off this call bridge until you figured out the root cause, and then you come up with a plan where you make sure this never happens again. And only then are you allowed off this call bridge. So because it's so horrible, we all do the right thing to make sure we never get on this call bridge ever again. So every developer check-in has to go through a pull request or a code review. So when I see somebody has checked something in and it needs to go through a pull request, a code review, I jump on it really quickly and I'm reviewing every single line with a fine-tooth comb because I don't want my teammates' bad code to put me onto this call bridge. I'm also not only just looking at their code, I'm looking at their unit tests as well, because I know that their unit tests, that's what's going to protect me from getting on this call. So I'm looking at everything super, super carefully, right? So you need to feel the pain of your own bad code. And once you do, our teams self-police and we end up doing the right thing. So that right there is what I mean about feel the pain of your own bad code. If you run it, or if you build it, you need to run it. So super, super important concept. All right, another thing that we did is we changed our branching structure to help us move quickly. So before, we used to have a lot of long-running branches, right? We'd have a dev branch, QAT branch, QA branch, UAT branch, long-living feature branches, so on and so forth, our production branch. The problem with these long-living branches is anytime you have to merge from one branch to another, at some point, eventually, you're going to get a merge bomb. You're going to get merge conflicts. And these merge conflicts, they were not easy or cheap or quick to fix. They were so difficult. They were such a pain. We needed to get rid of those. That really slowed down our velocity. So what we did is we adopted trunk-based development, where if I get a user story to do, I would spawn a branch really quickly, right? But this would just be a topic branch. I would wrap everything that I did in a feature flag, and then I would merge quickly back into the master branch or the main branch. So what this meant is there are no long living branches. And by having no long living branches, we wouldn't have these merge bombs or these code conflicts. And so that made our lives so much easier. And our code was protected because we used feature flags to wrap everything up. Now, because we wrapped everything up in feature flags, this gave us the added benefit that it separated our deployment of code from our releasing of features. And this brought up all sorts of advanced DevOps techniques that we could use, right? We could do blue-green testing using feature flaggings, or we could do safe deployments or canary deploys and things like that. And rollbacks became super easy because we could just turn off the flag. So that really helped us. I'm a huge fan of feature flags. Of course, feature flags comes with a price as well, because basically they're just if statements. So the more flags you have, the harder it is to test and the more complex your code becomes. But for us, feature flags, the price you have to pay for feature flags, that tax, it's so worth it because the benefits that you gain way outweigh the price that you have to pay. But we do have rules in place, right? Once a feature reaches production full time, you need to clean up your feature flags. No ifs, ands, or buts. Because if you don't and just leave your feature flags around, it clutters up your code and things can really spin out of control. But again, this was great for us. All right, finally, these are the changes that we did, right, from before to after. And some of them we jumped in more detail than others, and it's worked out extremely well for us. But whenever I tell the story, it really seems like, hey, we did this just like that, right? Microsoft figured it out and it was super easy. Nothing could be further from the truth. It was very, very difficult to do, and it took us a very long time as well. And in fact, we're still iterating and getting better from one sprint to the next. Because remember, DevOps is not a one and done. You don't just buy DevOps and then magically you have it, right? DevOps is a process of continuous improvement. It is a journey of continuous improvement from one sprint to the next sprint, where you ask yourself, what hurt the most? And you fix that one thing. And then at the end of that iteration, you look at it again and say, what hurts the most? And you try to fix that as well. So it's a continuous journey of learning, and it never ends. All right, thank you all so much. This has been Microsoft's DevOps journey. Hopefully, it's giving you some inspiration. It's giving you some of the lessons we've learned. It's giving you some ideas, and it's giving you some ideas on what not to do as well. Thank you all so much. If you have questions, feel free to reach out to me on Twitter @AbelSquidhead. I answer all my questions. Thank you all so much.